Assalamu alaikum.
Walaikum assalam, sir.
How are you all?
Fine, sir. How are you?
Alhamdulillah, fine.
Alhamdulillah, fine, sir. How are you?
Alhamdulillah, fine. I will take your Viva at the end of the class, okay?
Okay, sir.
In last class, we have defined Bernoulli's principle. Okay. Let me define some application. First is Torres-Lee's law. It defines velocity of efflux. What do you mean by velocity of efflux? I will define you later. Suppose you have any open tank in which there is a hole and liquid is filled up to this point. Let's say height of liquid in this tank is h and a hole is cut at depth h below its top surface, which may create some pressure due to which liquid will eject out through this hole with some velocity. That velocity of liquid of ejection out through this hole is called efflux, which we have to calculate. So this is VE. So height of this particular point from bottom will be H minus S. Now, behave this particular term like tube. Let's say this is one end of tube. And this is the other end of tube, like this. So it is exposed to atmosphere directly. So it will have some atmospheric pressure. And similarly, this hole is also exposed to air. So it will have atmospheric pressure P0. Now, we have to calculate velocity of efflux related to this entire segment. You'll say on ejecting liquid through this hole, the level of liquid from its top end may decrease, but this hole is very small as compared to the surface which is exposed to air and this open part. So area is very large. So velocity of falling down of level of liquid at this instant will be almost zero. Hamza, is it clear?
Yes, sir.
Let's say this is first position and this is second position. So we have to apply Bernoulli's principle for this first end as well as this second end. Consider a tank open in which liquid having density rho is filled up to height h. a hole is cut out at edge below the surface through which ejecting liquid will have velocity VE, that is velocity of efflux. Salman, any doubt related to this diagram? Okay. So according to Bernoulli's principle, you can say, according to Bernoulli's principle, at first point, P1 half rho V1 square plus rho G H1 equals to P2 plus half rho V2 square plus rho G H2. Now P1 is exposed to atmosphere, so it will be P0. V1 is almost 0, so it will be 0. Rho G H1 is capital H. P2 is equals to P0, atmospheric pressure. Half rho V2 is velocity of ejecting liquid, VE, and rho G H2 is H minus H. So on expanding, you will get this expression. Now, in this part, P0 and P0 will cancel out. Rho GH and rho GH will cancel out. So move this part, rho GH to left side. So you'll get rho GH equals to half rho VE square. Rho and rho cancel out. So velocity of efflux will be equals to 2GH. Is it clear, Hamza?
Yes, sir.
Now, what is special about this formula? Let me define you. Suppose you have a body. Let's say this, which is dropped from some height. So its initial velocity will be 0. So on falling through height h under the effect of gravity or free fall, if you have to calculate its velocity at this point, let's say v. So using third equation, we can say v square equals to u square plus of 2as. Khalid, is it clear?
Yes, sir.
So u in this case is 0. A will be gravity and s will be h. So v using this equation will be root under 2gh. Now just try to compare these two expressions. Is this, or are the two equations same or different?
Same.
It's
So we can
same.
say this falling liquid through height h behaves as particle. So it will attain same velocity as attained by any free falling body. Is it clear?
Yes, sir.
So we can conclude from this part. Hence, it behaves as free falling body under the effect of gravity. So according to Torus law, it says if liquid falls through height h, it behaves as same as falling a body under the effect of gravity. So it will attain same velocity as attained by falling particle under the effect of gravity. Hiba, any doubt?
No, sir.
Okay, just write it down.
Done, sir.
Now, related to this velocity and this phenomena, we can say, let's say this is y-axis, x-axis, and there was a hole at this height with respect to ground, h minus h, through which liquid is ejecting horizontally at some velocity VE. So it will follow this trajectory to hit the ground at this point. Is it behaving like projectile? Hamza? What we have done in chapter 4 for horizontal projectile?
Yes, sir.
So you'll be asked to calculate range, time of flight of that ejecting liquid related to this expression. So let me define you how to calculate. So time taken by liquid to hit the ground. So according to equation of motion, S equals to ut plus half at squared. So we are considering along y-axis. So displacement in y-axis is h minus h. Initial velocity along y-axis is 0. And the acceleration along y-axis will be gravity times t squared. So in this case, t will be equals to 2 times h minus h divided by gravity root under. Khalid, is it clear?
Yes, sir.
Now, if you have to calculate horizontal range related to this expression, horizontal range, it would be along x-axis. So displacement along x-axis will be initial velocity into time, half acceleration along x-axis into time squared. Since there will be no acceleration along x-axis, since velocity along x-axis will be 0, displacement along x-axis is r, initial velocity along x-axis is velocity of efflux into time taken plus 0. Put the value of velocity of efflux 2gh multiplied by time taken 2 times h minus h divided by gravity. So gravity and gravity will cancel out. So r will be equals to 2 times root under h into h minus h. Hiba, any doubt?
No, sir.
Now you'll be asked, what will be the condition for having maximum range? So if a function to have maximum value or minimum value, just differentiate that part and put it to 0. So on solving for maximum range, differentiate that r with respect to small h and put it to 0, you'll get h equals to h by 2. It means holes should be met at the midpoint of this tank so that you'll get maximum range. So R maximum will be equals to height of level of liquid in the tank. Hamza, any doubt?
No, sir.
If you suppose the hole should be met at the lowest point or at the bottom point, so for that part, time period or time taken by the liquid to hit the ground will be 0 using this expression. If you suppose the hole should be met at the highest point, so for that part, velocity of efflux will become 0. So the range should be maximum only at this given condition. Khalid, any doubt?
No, sir.
Okay, just write it down.
Fine, sir.
In an open tank, in which liquid is filled up to 8 meter. Find first velocity of efflux for a point having gauge pressure equals to this liquid is water, five into 10 to the power 4 Pascal. Find position of hole to have maximum range. Just try to find. Let me give you a hint how to solve this part. In first part, we have gauge pressure is equals to this. Hamza, just tell me what will be the formula of gauge pressure? Khalid, it was
Yes, sir.
rho GH. Okay. Now just equate this part
Yes, sir.
to this part. You will get the value of H. Put that in the value of the equation of velocity of efflux to get it, and also find range for this segment. Try to find using this expression. Density of water is 10 to the power 3. Take gravity to be 10. Khalid, this is total height of tank up to which liquid is filled. And this is gauge pressure from which you get the value of a small h. Good. Hamza, how you have calculated the value of height? We have gauge pressure as 5 into 10 to the power 4. Density of water will be 10 to the power 3 and gravity is 10. Just solve this.
Okay, sir, I have miscalculated.
Good, Salman. Just put this value in the formula of velocity of efflux. Good, Salman. Khalid, just check your calculation for the second part. Good, Hamza.
Sir, could you show the range formula again?
This part,
Oh, I wrote the formula wrong. Okay.
Salman, just take the formula which you have used. Good, Salman. Try to find the third part. Good, Khalid. If you solve this part, 10 to the power 4, 10 to the power 4 will cancel out. So h will you get 5 meter. According to formula for velocity of efflux, 2gh, 2g is gravity, h is 5. So it will be 100 root under, so it will be 10 meter per second. Range related to this part will be 2 times root under h into h minus h. So 2 root under, point of hole in this part is 5. So 8 minus 5 will be 3. 2 root 15 meter. Hiba, is it clear? Hamza, any doubt?
No, sir.
Just tell me the answer for third part. What should be the position of hole to have maximum range? Just tell me what is the height of tank?
Tank is 8 meters, right?
Sir, 8 meters?
Just use this condition. For maximum range, holes should be met at what point? At
Height of the-
midpoint. So it will be 8 divided by 2. Is it clear?
Yes, sir.
So it will be 4 meter. Khalid, you have to calculate the position of hole, not the maximum range. Okay?
Okay, sir.
Hamza, any doubt?
No, sir.
You have written up to this part?
Yes, sir.
Now there will be a question related to this. If whole tank is allowed to fall freely under gravity, then what will happen to its velocity of efflux? Khalid, just tell me what would be the acceleration or net acceleration under free fall?
0.
Good. So in this condition, net acceleration will be 0. So velocity of efflux is equals to root under 2 times of gh. Here g is nothing but net acceleration. So if you put the value of net acceleration to be 0, you will get 0. It means under free fall, there will be no condition of ejecting out of liquid. Is it clear?
Yes, sir.
So liquid will not eject out. Salman, get it out.
Can you explain what is the V that is equal to root 2GF? What
V equals to, that is velocity of efflux equals to under root 2gh. Here g is nothing but net acceleration of that particular system.
Yes.
Initially, we are considering the tank in the initially at rest. So the liquid must be accelerating towards downward due to the effect of gravity only. So net acceleration of liquid in that case was gravity. Now, if suppose the whole tank is allowed to fall freely under the effect of gravity, so under free fall, net acceleration becomes 0. So replace this particular g by 0, you will get 0 velocity of efflux. It means liquid will remain stuck to the tank. It will not come out. So it will be 0, or velocity of efflux in this case will be 0.
Yeah. I understand.
Any doubt related to this part? Okay, just write it down. Hamza, written?
Yes, sir.
Okay, now there will be question, what will happen if tank is closed? So for closed tank, in which liquid is at up to this height, and due to pressure difference, it will tend to go or eject out to reach at this point. So it will be velocity of efflux. Height of tank in this case, h. Position of hole from this point, h. And from bottom, h minus h. There will be some pressure inside, and since it is exposed to atmosphere, so it will have atmospheric pressure. Consider this entire part in the form of tube like this. So let's say this is position first and this is position second. Velocity of liquid going downward at this first point will be almost zero. So using Bernoulli's principle, you will say P1 plus half rho V1 plus rho GH1 equals to P2 plus half rho V2 plus rho GH2. Putting the value of each term in this expression, P1 is Pi, that is inside pressure, V1 is 0, rho GH1, that is H, P2 is outside pressure, half rho V2 is velocity of ejecting liquid, efflux, and is rho GH minus rho G small h. This part will cancel out. Move this P naught to left side. So Pi minus P naught. And also rho GH to left side. You will get half rho velocity of efflux squared. On solving this expression, velocity of efflux will be 2 times GH plus pressure difference divided by rho multiplied by 2 root under. So it will give you some larger value of velocity of efflux due to this pressure difference. Is it clear? Hamza, any doubt?
No doubt, sir.
And if you put the value of Pi equals to P naught in the case of open tank, Pi equals to P naught, the difference of these two terms will become 0. So you'll get the same expression what we have calculated above. So you may be asked to calculate pressure velocity of efflux for closed tank or open tank. Khalid, any doubt?
No, sir.
Just write it down. Salman, done?
Wait a second, sir. Yes, sir.
Hamza, written?
Yes, sir.
Okay, next is Venturi Meter. It is just an instrument which is used to measure velocity of liquid at any instant. So it is an instrument used to measure velocity of liquid at any instant. And this particular topic is removed or deleted from your course. So I'm not deriving this part. Next is Magnus Effect. Suppose you have any spherical ball if you throw this particular ball without spinning, so it may follow this trajectory to fall at this point. This is the case of without spinning. So what will happen if you throw this particular ball by spinning in clockwise direction? Will there be any effect in its trajectory, or it will remain same? Hamza, any guess?
Sir, in clockwise.
Yes. Let me define its mechanism. Suppose if you throw this particular ball in clockwise spinning, so air around it must be going along this way. For this part must be along this way. So this is movement of air. Now just compare or try to calculate net velocity at this highest point. 1 for this point, for clockwise direction, velocity is in forward direction and its air movement in backward direction. So net velocity of air at this point will get decreased. Is it clear? Since
Yes, sir.
both these two motions in opposite direction. And similarly in bottom point, since both are in same direction, so velocity will get increased. According to Bernoulli's principle, pressure plus half rho v squared, since height is same. So if velocity is increasing, pressure must be decreasing. And if velocity is decreasing, pressure must be increasing. Is it clear? So
Yes,
in the
sir.
above part, since velocity is decreasing, so they should have increase in pressure. And the lower segment, if velocity is increasing, so there would be decrease in pressure like this. Hamza, is it clear?
Yes, sir.
Now, which side we have higher pressure, upper side or lower side?
Upper side.
So matter will tend to move from higher pressure to lower pressure. So will there be any movement towards downward direction, or will there any deflection of this ball from its actual trajectory towards downward direction or not? You will say yes, due to this pressure difference. So it will tend to go along this way, the head at this point. So this will be a case of clockwise spinning. Hamza, is it clear?
Yes, sir.
And similarly, what will happen if you throw it in anti-clockwise direction? It will follow this trajectory, the hit at this point. So this will be a case of anti clockwise spinning, and the middle part, no spinning. Khalid, is it clear?
Yes, sir.
Okay, just write it down. Done.
Yes, sir, done.
This is all about mechanical properties of fluid. Okay. Next, we start with thermal properties of matter. In this part, first, what do you mean by temperature? Khalid, any idea?
I have an idea about it, but I can't say it in a definition. I can't make up
Okay,
words for the definition.
just say what you know about it in your own way. What is temperature? Hamza?
Sir, it is the heat, heat or the cold of any substance.
Okay, close enough. Suppose this is any object. If you touch this particular object in summer, you will feel nothing. But if you touch this particular object in winter, you will feel some cold. Okay, so you'll say we measure any object related to the body temperature of ourselves, how much it is colder or how much it is hot related to our body temperature. That measure basically defines you the temperature. So temperature is measurement of degree of hotness or coldness related to some specific value. In this case, we'll take melting point of ice and boiling point of water. Is it clear?
Yes, sir.
Yes, sir.
So temperature is the measure of degree of hotness or coldness of a body. It is just a relative term which is defined on the basis of some reference. It is defined on the basis of melting point of ice and boiling point of water. SI unit is Kelvin and is measured by an instrument called thermometer. This thermometer will be of two types depending upon its range and its uses. First is called clinical thermometer and second is called laboratory thermometer. I will define you the other definition of this temperature according to thermodynamics in next chapter. So clinical thermometer is which ranges human body temperature, that is from 35 degrees Celsius to 42 degrees Celsius. In laboratory thermometer, we define on the basis of melting point of ice, it is also called ice point. So it will be 0 degrees Celsius. And next is boiling point of water. It is also called steam point, 100 degrees Celsius. Salman, any doubt? Now, to define scale for measurement of temperature in any different form, let me define you a generalized formula. So for scale for measuring temperature, T minus LFP divided by UFP minus LFP will be always constant. In this part, T is temperature on the scale which we are using. LFP is lower fixed point. UFP is upper fixed point. Any doubt related to this part?